So I will continue what we explained yesterday. Let me move on. I think we stopped by slide number 22, as far as I remember. So I already explained how to get the plane structure of the hexagonal. You know, you have to find the intercept with x and y and z. Then you make a reciprocal, and after that you try to find the minimum integer, and then add the force axis. I think so. We did this yesterday, right? Shabab, is that clear? Shabab, you hearing me?
Yes, Doctor, clear.
Yes.
So we have another plane. If you see the green one, if you look at here, one of the students may answer. What's the intersection with x? What could be the intersection with x?
-1.
-1.
Excellent, excellent, excellent. And intersection with y?
Zero.
And means when we
Not zero,
Infinity.
not zero, infinity. If it's parallel, we say infinity. So 1 infinity. And what is y? Is that? What do you see?
1.
Infinity also. Infinity.
Infinity as well, because it's parallel to y and parallel to z. That is why two infinities. If you look at here, is -1 infinity infinity. Just to make the second step is to make a reciprocal, as you seen it here, transfer to -1, 0, 0. So all of them is integer. It's okay just to go and find the force axis. How to find the force axis? Minus summation of this two. Okay? You get it here, minus h and k. So it's 1. You can write the plane in that way. This is a standard way. This is called the standard way. Standard plane in hexagonal shape. Okay, it will be written in that way. Okay, come to the other part. We'll explain it today. It's called linear dynasty. Okay, we have planar dynasty and linear dynasty. Let me just go here, and I'm trying to explain in a different way. You may understand in a better way. Whenever you have a hexagonal or what's cube, okay, in that cube, for example, let me say body-centered cubic structure. I think all of you know it. We have atoms at the corner, and we have atoms at the middle, right? Are you following, Shabab? Shabab?
Yes, Doctor.
Yes, Doctor.
Yes, Doctor.
Linear dynasty, it could be calculated in that way, is equal. The number of atoms in certain direction. I think already you learn how to find the direction, okay? Divided by the length of the direction. Length of direction. So the length of the direction inside is very important, that one. The crystal. What is this? If, for example, I know, and I think most of you know this one. Can you mention this is direction? This is direction. Say this V1. Okay. Okay, Shabab. So the length of the direction V1, if this, for example, this is A is this unit cell length, and this is body center the cubic structure. We know A is equal 4 over root 3 R. If you know the radius of atoms, you can find A. Is that clear, Shabab? So I need to find in this direction, it's called V1, find the linear dynasty. Okay, look at here, I will take it out. If you look at here, I have two atoms in this direction. If you look at here, how much atoms is here? Is half, and here is half. Even inside this direction, lower V, we have 1 atom. Is that clear, Shabab? You see? يبقى you have 1 atoms because it's here half and half. Okay, يبقى number of the atom passing through this direction is 1 atom. Okay, and the length is 4/√3r. If the length, for example, in nanometer, we can say 1 divided 4√3r. It will be, once you find that one, it will be atoms الوحده بتاعتها يا شباب. Atom per nanometer, because this length in nanometer. If I need it in millimeter, transfer the nano to milli and so on. I think it's clear. Let me go with the example. You will understand in a better way. Let me go ahead. Here, I will explain it. Shabab, are you hearing me? Should I continue?
Yes, Doctor.
Okay.
Yes,
Let me
Doctor,
go
yes.
ahead. I give you some example, and I think it's very easy student to understand. Number of the atoms in a certain direction. Of course, I will give you the direction and the unit length of the direction. Just measure what is this length. Okay, let me go ahead. For example, I give you example like this. This is a face-centered cubic structure. We know in a face-centered cubic structure, 1 atom in the corner and 1 atom in each face. I make the atom in the face as blue color and the corner in red color, as you seen it here. I'm asking you to find, okay, in this case, the radius of the atom is 0.1431 nanometer for this direction. Sorry, Shabab, because this direction is not clear here, I will just change it for you. The direction I needed, اللي هو كام يا شباب؟ 110. Okay, so if you look 110, this means that this direction. Do you see this, Shabab? شايفين الدايركشن ده؟ You seen it or not?
Yes.
Yes.
Okay, let me take it out here. So this is like diagonal of the square, right? ده diagonal بتاع السكوير يا شباب. If this A and this A, can you give me this length? Yes, I can find D is equal ρ2A. I think each student is supposed to know how to get this one. If you need to find the diagonal of the square and the length of the square is A, isn't it diagonal? The diagonal will be ρ2A. Now, a length is given. Length given or calculated. How many atoms there? Let me take it out here. If I put the atom, we have 1 atom as a corner here, and 1 atom here, and 1 atom in another corner. If you take it out here, it will be clear like this. This is shared by half. يبقى here half. This is 1, and this is shared by half. So the number of the atom بكام يا شباب؟ حد يقول لي كده؟
2.
Excellent. يبقى number ب2. And length, let me go and calculate the length for you. R, the radius of the atom is 0.1431 nanometer. Please consider the units. Shabab, it's very important after finishing this class, before you leave, because I will not say it again. Just remind me, I need to say something regarding to the quiz number 1, okay? So if this radius R, we need to find the distance D, okay? Because this is a linear dynasty is equal to number of atoms by D. D, this is the length of direction, okay? So how to find D? We know D is equal ρ2A, and we know, as I told you, for most of these cases, I will give you the relation between A and R, because this is a face-centered cubic structure. A is equal to ρ2R. So I can write it in that way. ρ2 multiplied with 2 ρ2R. So it will be 4R. Okay? D is equal to 4R. 4 multiplied with 1431. It will be, if you calculate it in that way, you can find the unit length. Is that clear, ya shabab? Ya shabab?
Yes,
Shabab.
clear.
It's clear, ya shabab? So if you have calculator, please try to calculate it for me, because I don't get it. You can get it in that way. So it will be 2 divided by 4.
It would be 0.5724.
0.5.
5724.
724. اوكي شباب، what is the unit will be؟ حد يقول لي اليونت.
The unit
Atom
is
per-
atom per nanometer.
Say it again.
Atom
per
per nanometer.
This is atom per nanometers. Okay, excellent. But if I'm asking you to find the linear density in atoms per centimeter, how to do it?
I will multiply the denominator by 100 by 10 to the power minus 7.
-7 from nano to centi. يبقى minus
Yes.
7. Is that correct يا شباب? Excellent. This is correct.
Yes,
So
The
you will get
denominator.
a big number. Yes, denominator you will multiply it with the negative power, right? This means it go to the positive power. Is that clear يا شباب? شباب,
Yes.
is that clear? طيب, if I'm asking you, come back, I think it's very clear. Each student is supposed to know how to get it. If I'm asking you, is this direction? Yes.
How did we get the distance?
The distance is the diagonal. Look at this. Do you see that one? What I'm drawing here? You see it or not?
Yeah.
If this is direction is the diagonal of the square. Diagonal of the square, because I'm asking you this direction. And this is diagonal of the square. If this is A and this is A, use Pythagoras, you can find the diagonal. If you don't find the diagonal like this, I will not answer you, because this is, I think, maybe of high school or primary school. How to find this diagonal? How to find it? This is the length of, again, if I'm asking you here, this one, I need this direction. Do you see this direction? You seen it or not?
Yeah.
Yes.
Okay. Can you find the length of this direction? Yes, the length here is A. And how to find A? Because this is a face-centered cubic structure, as I mentioned here, we have relation between A and R. A is equal to rho 2 R. Yeah, I can find A. A here is the distance. But our distance from the beginning, I'm telling you this direction, 110. How to get 110? This direction, diagonal of the square. Diagonal of the square. Okay? Do you know how to find this diagonal? You know it or not?
Yes.
It's very clear. I think this is maybe primary school or prep school or maybe high school, and you already study in you will study in many cases how to get it there. If you have a square like this, and we know the side length, the diagonal always rho 2 multiplied by the length of the square side length. Anyway, let me move forward. If I understand now, you understand شباب, how to get the direction. Is that clear يا شباب؟ شباب.
Yes, doctor, clear.
Okay. طب again, لو انا اتكلمت عن الهكساجونال، and you try it in home if you want. If I'm asking you this direction, okay, I know there is one atom here and one atom here and one atom here, right? This is diagonal, right يا شباب? I'm asking for this direction. Again, that one. Find the linear density. Linear density. Okay, what is D? مش ده الهكساجون. This is D. D is equal to 2A. Okay? D is equal to A. يبقى the distance is given here. And what is the relation between A and R? And I think for hexagon, A is equal to R. So I can say D is equal 2 multiplied to R, it will be 4R. يبقى the distance is given. How many atoms here? حد يقول لي كم atoms here يا شباب؟
2 atoms.
2.
Yes, here is half, 1 and half. So N is equal to, the same like previous. يبقى here we can see 2 over 4R. It will be 1 over 2R. If this nanometer, you can find it in that way. Atom per nanometer. It's very simple to get it, by the way. Just train yourself how to get it. Let me move forward. There's lots of phrasing. I don't know what happened here. Sorry يا شباب.
No problem.
Again يا شباب, we already explained this. Just go ahead. Okay. We finished the linear dynasty here. We explained many examples. Come to the planar dynasty. Again يا شباب. If I'm talking about the planar dynasty, I'm talking about the unit cell as well. If I have a cube, for example, cube unit cell, whatever the cases, I give it to you, like this. We have n atoms in a corner, and for example, and 1 atoms in the middle. This is body-centered cubic structure. So how to find the planar dynasty? First of all, I give you the plane. Can you mention if this is, for example, Ishwab, just a revision, you take it before, X, Y, Z. This plane, how do you look at the plane ده اللي فوق ده? Can you give me this plane? Tell me the standard plane of that one. How to get
0,
it?
0, 1.
And 0, 0, 1.
Excellent. 0, 0, 1. Excellent. If I'm asking you, find if this is radius, for example, I give you the radius of the atom, 0.101 nanometer. Okay, Shabab? Just I give you one example right now, and we'll solve it together. I'm asking you, find the planar dynasty PD, and a planar dynasty of body-centered cubic structure. If I mentioned the crystal structure of plane, only يا شباب 0, 0, 1. So the first things, I will take the plane out. I take this plane. Is the square, right, يا شباب? Is that square? We have only atoms at the corner. Now I am talking about the area, Shabab. I'm talking about the area. It's very important students to understand. First, find number of atoms in the plane. تعال نجيبها مع بعض كده يا شباب. Look at here يا شباب. الاتوم دي فيها كام من البلين؟ حد يقول لي كام؟
1 atom.
1 atom.
Quarter in each corner.
This is 1/4. Quarter. صح يا شباب؟ يبقى number of atom here
Yes.
is 4 multiplied by 1/4. It will be 1. Excellent. You get it in that way. يبقى number of the atom is given. Planar dynasty is equal to the definition here. عبارة عن number of atoms divided by the area of the plane. Area of plane. اوكي يا شباب؟ تعال نجيب الاريا يا شباب. حد يقول لي الاريا بتساوي
A square.
ده سكوير. Excellent. A square. طب what is the relation between A and R? As I made promising you, all of you, I will give you the relation for the 4 cases I've done.
4 divided by root 3 R.
I think everything is given now. We can say planar dynasty is equal, for that plane, is equal to 1 atoms, because we have 1 divided by A square. 4 root 3 R all square. What is the unit here? حد يقول لي اليونت هتبقى ايه يا شباب؟ If this is in nanometer, it will be atoms
Atom
per
in nanometer square.
Nanometer square. Excellent. You get it in that way. Is that clear يا شباب؟ شباب.
Yes.
Clear or not?
Yes.
Clear.
Okay. Type. If I'm asking you, come to the hexagon. because it's not mentioned in this part, and I almost am finished. I have one part to explain it. I don't know I have time to do it or not. If I'm talking about the plane, that plane اللي هو هنا اللي هو ده اللي فوق ده شباب. Do you see? حد يقول لي البلين ده عباره عن ايه؟ ها برضه 0 0 0 1 right؟ البلين ده 0 0 0 ما فيش غير في زد بس يعني. Okay? Is cutting Z and parallel to X and Y, right? So if I'm asking you find the planar density of this plane, let me put it here. I will take it out. This is my plane, right, يا شباب? And try to put the atoms. We have atoms in the middle here and atoms in the corner. Is that clear يا شباب؟ شباب clear or not?
Clear, Doctor.
It's not written, by the way. I'm trying to learn you the way of solving. Maybe I will give you thousands of examples to solve it, but you don't understand. If you understand what I'm giving you, it's enough for you. It's totally enough. You can go through and try to solve yourself whatever complicated problem. If I'm asking you one question here, how many atoms bear this plane or planar density n على الاريا صح؟ تعال نعد مع بعض يا شباب. This is 1, right? صح؟ This is totally 1.
Yes.
طيب how much inside here? 1/3 صح يا شباب؟ اما يكون الزاويه دي 120 120 يبقى this is 1/3 of the 1/3 يبقى دي 1/3. This is 1/3.
1/3
This is
multiplied. It would be 2.
1/3. 1/3. 1/3. Let me calculate it with you. N is equal. We have 1 in the middle plus 6 multiplied by 1/3. تطلع بكام يا شباب؟ توتال بكام؟
3.
يبقى N ب 3. طب الاريا يا شباب؟ I think we explained it before. One of the students can answer me. This is 6 equilateral triangle. صح يا شباب؟ يبقى الاريا is equal to 6 multiplied
6
half as
by 60.
A square sine 60. That's all. We get the area here. طب what is the relation between A and R? A is equal to 2R. So once you get R, you can find A, you can find the area, you can find the planar density. Is that clear يا شباب? And the unit, if this nanometer, you can say atoms per nanometer. Can you continue in home and find the value? Yes.
Square.
Sure, yes. Sure. Is that clear?
Yes.
Yes, clear.
We take square of nanometer, isn't?
Yeah, of course.
Okay.
Area square. This is something multiplied with A square, right?
Yes.
So the planar density is very easy to get it and to capture. Number of the atom in certain plane divided by the area of the plane. You can get it like this. If I'm asking you, solve it with me, that one. This is a body center the cubic structure. Okay, as a plane 101. I think I give you many examples right now. I will take this out. Look at here, Shabab. I will take this out, and I think you may understand in this way. This plane. This length is A. مش ده A يا شباب؟ صح ولا لا؟ شباب؟
Yes.
شباب. And that one حد يقول لي ده. ده root 2A. صح يا شباب؟
Yes, the
Yes.
diagonal of
عشان ده
the
diagonal.
square.
So the area is given here. You can count the area. Area is equal. حد يقول لي كام؟ root 2
A square.
Root 2A square.
A square. Excellent. And what's the relation between A and R? A is equal 4
4/root
3
3R.
R. You can find the area. If area is given. How many atoms? Let me go ahead. We have one in the middle and we have one in each corner. So look here. This is 1 calculated as 1, but this is 1/4. صح؟ 1/4 by 4 يبقى number n بكام؟ بكام يا شباب؟ 2.
2.
Is that clear? Is that clear or not?
Clear.
Yes.
So we can find n, and A is given. You can find everything is in that way. So you can count it in that way. You find A. The unit will be atoms per nanometer square. Atoms per nanometer square. Is that clear, Shabab? Shabab, you
Yes.
understand this part or not?
Clear.
Okay, I'm finished this part. I have to add something. It's called X-ray diffraction. Should I explain it or should I remove it from the course this semester? What do you want?
Let's remove it.
Okay.
To you.
Remote will be better.
No, it's okay. What? Say it again. Every student like removals.
Doctor, if it's important,